Afternoon, everyone. Can you hear me?
Yep.
Okay,
Yeah.
excellent.
Hmm.
This afternoon, we have Andrew who will be sharing with us his work with ASMS. And then my colleague Wei Ting has prepared the presentation, but she's unable to present today. So I will be presenting on her behalf. All right. Andrew, it's 4:05. I'm very mindful of the Australian time, so I've stopped screen and I'm going to hand the screen over to you.
No worries. Thank you very much. I'll just make sure you are. No worries. We good to go?
Good.
Okay, good. Well, good evening from here, but good. Hope you have a good day, whatever time of day it is where you're listening to this. Um, as introduced, my name is Andy Stone from the Australian Science and Maths School in Adelaide, Australia. What I'm going to be talking about is I guess, an experiment. We're more than halfway through at the moment. Things are going well, but we are using a new elective central study at the moment. So I'm just going to have a chat about how it is going. Okay, so what I'm going to setting the scene, I guess. The SMS, where we're from, why we wanted to explore a new central study in the first place. Um, how does the whole central study work together? And then going to spend a little bit of time looking at a couple of examples of individual electives. Hopefully, I'll be able to get some suggestions for new ones as well. Okay, so I know that Shan, you've been to the RSMS, but so we are in Adelaide, Australia. So if you can see in that bottom image, the little red dot right down the bottom, lovely town of City of Adelaide is the RSMS. Okay, so we are a senior school only focusing on the final 3 years of schooling. So that's 10, 11, and 12. So students are 15 to 18 years of age. And we have a focus on STEM education. So it's a real strong focus on science, technology, maths, and engineering through our curriculum. Having said that, we do cover a lot of other curriculum areas, but that is our focus curriculum areas. In years 10 and 11, the students are organised, or the curriculum is organised into chunks that I'll call central studies, that are called central studies. So at the moment, if you can you see my mouse if I move it around on the slide? I'm going to be talking about the X and Y central study. So at any one time, students are really only doing 3 STEM central studies and additional 1 learning studies, which is their home group, care group, a lot of associated learning. So at the moment, students are doing Sustainable Futures and Engineering in Monster and this subject called X and Y. And that's what I want to talk about, X and Y. But I do want to have a little quick look at this ribbon diagram. What it means next year is students will be moving into Earth and Cosmos, Truth and Perception, Terra Knowing. So there is a flow, a 2-year sequence of these interdisciplinary central studies. And across all of them together, the students are exposed to the learning that they need to achieve and that interests them across science, technology, maths, engineering, English, media to succeed in the final year of schooling and beyond. So what we are doing, so our new central study, I just want to talk a little bit about why we decided to have a new central study. I guess in the design of this central study, we had these 8 goals. Okay, so the belief that this central study needs to achieve these 8 things. Now, what I'm not saying here is that we weren't already doing these things. I guess what we were looking at, can we do it differently or better, or what other ways are there of doing it? The central studies as they exist now tend to have a teaching team of 10 teachers with 12 individual classes. When you're dealing with such a big team and so many classes at the same time, I think sometimes what we've found is being innovative and trying new things is not easy, because you got to get another 10 teachers on board and there's 12 different classrooms, and just organizing the materials and speaking to the lab managers is just becoming a bit, it was slowing us down in some ways. Okay, so these goals, what we want is enhanced engagement and relevance. Like we want the learning to matter to students. Okay, nurturing lifelong learning. It's a goal across, all of these are goals across all of our curriculum. But I guess the new central study is, can we do this differently? Building individual responsibility of the learners, promoting critical thinking and decision making in the learners, encourage personalized learning. So what we want for our students is not just learning content, but learning content in a way and in a connected way that matters to them. So there may be a skill, like how can they develop that skill that matters to them? We want to support collaboration and leadership. So that number 6, I guess, collaboration and leadership, like we're looking for that amongst students, but to be honest, leading this central study, I want to see that in my staff as well. Like, can they work together? Can they support each other? Can they make each other a better teacher? We want to address students' diverse needs. Now, that is not just their interests or their passions, but what do they need to be the best learners they can be? Okay, some students need a variety of ways of learning or content matter. Can we cater for that even more? And number 8, flexibility in teaching methods. To be honest, I think number 8 is the one that interests me the most, because I'm of the belief that if I can give my amazing staff time and space to be flexible and make smart decisions on how their learners can best learn, I'm probably going to get all of the other criteria done because they're high quality professionals. I mentioned earlier, big teams can be not hard work, but can be slow. Like there's time put into teamwork. We have less of that in this new model, and it does mean that we miss out some of the benefits of teamwork, but we're trying our best. Okay, so X and Y, the module. How it works is that students are offered 18 different modules and they need to choose 4 of those, okay? And the 4 modules together constitute the new central study. We had approximately 260 students are enrolled in this central study. I think there's 230 different patterns of choices that students made once you include the order in which they do it. So students are doing different things. All of these modules are interdisciplinary. Some have a stronger maths focus, some have a stronger science focus, but they will be selected and co-designed with students, with staff. And one thing I was keen on is to make sure that we get significant connections with external partners. The ISSN is on the Flinders University campus. So we have less than a 10-minute walk away, an amazing university site, which gives us relatively easy access to partners. It doesn't always turn into effective partnerships, but that's one thing that I was looking to leverage in this. So what does it look like? Some of the practicality or timetable outcomes mean that the X and Y module, there's 4 100-minute lessons per week. Okay, each module experiences that for 4 weeks. So in essence, there's 1,600 minutes of teaching time for each module, and there's 4 rotations across the semester. We are at this point about halfway through our 3rd rotation. Okay, at the end of this week, our 3rd rotation is over. A 3rd rotation is halfway through. We got a 2-week break because of holidays. I'll just stop there. Does anyone have any questions before I keep going?
Actually, I have a lot of questions. I mean, okay, I'm going to start the ball rolling because you've gotten me really curious. But anyone who wants to, please raise your hands and then so that we can see it. My first question is, this new central study that you have
Yep.
runs through your 4 terms of the school year, right? Am I hearing correct that now the student actually have, in essence, a choice of personalizing their course at high school at your school?
Yeah, so I'll just flick back to the ribbon diagram. So X and Y is only running in the second half, like the second semester. So in the second half of this year, students will be doing X and Y. So it's only been in the second half of this year that they've had this module approach. Does that answer the question?
Okay. I think it's this is a very new approach. I'm wondering if anyone else have questions before we let Andrew goes on, and then we get a little bit lost in the progress. Do we have questions from the other participants? Okay, I'll keep my questions to later.
No, that's all right. I just thought I'd stop halfway through to see if
Yeah.
before I completely lose people. All right, where are we up to? All right,
No,
so
you're too far ahead. Yeah, maybe
we've
here.
just done that one. Do this one here. So in designing the modules, this was at the end of last year. We had a number of meetings with staff and a number of meetings with prospective students to come up with what would students like, what would students like to be in the modules, what would staff like to teach in the modules. And I think it's fair to say there were some amazing ideas. There was quite a similarity between what students came up with and what staff came up with. Generally. But in terms of what do the modules look like, as you can see on the slide, the number one thing we need to look for is they have to be interdisciplinary. Okay, there's no module that's called maths or physics. Okay, there's certainly modules with maths and physics in them, but they have a strong interdisciplinary connection. Okay, it's so I'll go through in a minute some examples of that. Each module, and this is some of the practical things, particularly around what staff are asking me, each module has to generate 2 evidence of learnings. Okay, so in terms of are students assessed in their learning? Yes, there's 2 chunks of learning that they need to be assessed along. That could be, for instance, like there's a science investigation, and maybe there's more data analysis. Okay. So each module does this slightly differently, which I'm encouraging. I think what we want in these modules is to give our staff a chance to experiment. Not unlike evolution, sometimes we find the best way to do things. Some things are a dead end, but we still get learning from that. I talked about partnerships earlier. One of these modules, I guess the expectation for these modules is that they involve partnerships. There's lots of different ways this can look like. A lot of the modules I've been involved in, the partners haven't made a big presence in the classroom physically, but it's in the weeks leading up to the module they've been invaluable in helping me to design what does cutting edge look like, what are some ideas, what are some topics. The picture on the slide you can see is a class. We took them up to a lab at Flinders University, where there's a postgraduate student there in the lab coat who was sequencing some DNA some of my students had isolated in the previous week. So working with her in a lab enabled me to go, well, this is the project we're going to do. This is where we're going. And so students were able to, in the next day or two, collect real life sequence DNA data, which was amazing. The fourth one there, I've talked about interdisciplinary and STEM learning. What I didn't want to lose from these modules is the student's ability to read and analyze text. So each of the modules is expected to have at least some critical reading of text to keep working on their communication skills throughout this. And not surprisingly, the last one, it needs to be interesting. Certainly some modules were much more popular than others. Whether some run next time we do this, we'll wait and see. Some were very, very popular, and everyone in them was just not possible. So I think if we keep doing this, we're going to get feedback from students and staff. Some modules will come in, some will fall off depending on interest as we go. But I think all modules have achieved this. I know Brian's an audience member today, but I know he's been up to Flinders this week and is going up in 2 weeks' time, because we can. And I think one thing, the partnerships have been really good because we've got one class. It's much easier to get partners involved and say, hey, we've got 12 classes, which means we need to have a guest presentation 12 times. It's just one class. So a class visit is much easier for our partners than 12 class visits, okay, which I think it's certainly, in my experience, making those partnerships much easier to develop. Okay, so how are the modules chosen? There's kind of two big things. Number one, and the most important one, and why I put it as number one, is I'm hoping students are choosing this based on interest, possibly pathways, but I'm making the assumption that if they're interested in it, it may be a pathway, but they don't have to be the same thing. What we need to keep in mind, though, I talked earlier about there are assessment requirements in this central study across these modules. So there's a certain pattern that we need to ensure gets assessed. So there is some maths learning that we need to do. So when students are able to choose these modules, it's not just choose your top 4, but essentially is you need to choose one of these maths ones, you need to choose one of these science ones. So there's a set of regulations or rules, but certainly our year 10s, they're choosing 4 modules. Once you've chosen your maths one, once you've chosen your science one, there is kind of 2 other options. So most students can. Well, what I'm trying to say, I guess, is that the restrictions that the evidence of learning places aren't particularly onerous and don't restrict students. I'll just explain this 2 images. Talked about earlier that staff member from Flinders helping a sequence. I'm not sure if you can see the little light patch to the top of the agar plate. That is a bacteriophage that some of our students found. So that is what we essentially further cultured that and then sequenced the DNA. The results of that are very promising as far as we know and as far as we can tell. I'm hedging my bets here, but that is a phage that no one had discovered before. So now there's ongoing relationship with that lab to turn that into essentially some scientific publications where our students can contribute to science knowledge. The image down the bottom was from one of the modules called Sounds of Science, where after learning quite a bit about sound waves and the physics of sound waves, students were challenged to build their own instrument. And I think this is a really good example for, in my head, where students could apply their learning in the way that they wanted to. So they had some solid science, physics waves, and then they were given the challenge, like, use technology. We've got all of these materials, build an instrument. So this student's built, I'm not sure if you've ever put a ruler on the end of the desk and it makes that weird sound. They've essentially built an instrument that they've tuned, and they were able to play songs on that by the end of the module. Okay, so how modules chosen. What are our modules in 2025? So we have 18 different modules. I'm not going to go through them all in detail. What I might do, is there any modules that people want me to talk about? Is there ones that you go, oh, that sounds interesting, can you talk about that one? If you put it in the chat, I'll talk about those ones.
Trying to find out more. For some of the participants who have joined us late, Andrew is sharing a very new model of teaching and learning at ASMS. So either you could unmute and say, I want to find out more about this module, or, type in the chat. So we give people time to respond.
Yep. I'm happy to do that. If there's a module that you want to hear about, H2O no. That was going to be my favorite. One thing that I need to be careful of. I have favorite modules. I like that some of them. H2O no is one I desperately wanted to teach and be in. The timetable didn't let me. So H2O no. This is a good example of working with Flinders University staff. What in the middle of Flinders University, there's a lake. It's not a particularly big or clean lake. So the challenge there, once students have done some basics in water quality and water testing, we have like 20 liters of that lake water. And the challenge is they need to build, design, construct a way to clean that water, both chemically and biologically, to make the cleanest water possible. So they've tested the lake water, and then they get quite a bit of time to design a way to clean the lake water. So it's cloudiness and it's turbidity, and they've done bacterial counts and heavy metals. And the end thing is essentially going to have a glass, hopefully, of really clean water. So that's where H2ODO is. We work closely with the Department of Environmental Health for that one. So that activity, in essence, is a simplified second-year university task. So one of the things that we've benefited from with working with staff is that many of these, we're just using stuff that the Flinders Uni is already doing, and we're just creating high school friendly versions. Okay, Shirley has asked for breaking the rules. I might have to handball to Brian for this one in a sec. This is one that is responding to student interest really quite rapidly, agilely, if that's a word. What we were looking at there is looking at the rules in physics that start breaking down. So the classic example that jumps into my head is light a wave or a particle? Yes, but it's so much more than that. Traditionally in the South Australian curriculum, we don't necessarily go beyond that, but we've got students who love that ambiguity and want to push the boundaries above and beyond what's normally expected. Brian, have I captured that correctly?
Yeah, I think you've done a very good job so far. We're also expanding it from science to maths, because there are there are laws that apparently always work in maths until they don't. In the same way that there are rules and laws that we rely on in science, and we make a whole lot of predictions, and then sometimes they don't work. So trying to bring the idea through for students that understanding develops when unexpected things happen, and we're looking at how models develop and how evidence is used to change people's minds.
That's a cool one. Thank you very much, Brian. So Mega Evolution is one where students have used the Mega software, which is freely available and online. And it's a bioinformatic database. So students designed and constructed their own online investigation using DNA and protein sequences to find out about evolutionary relationships between animals or plants. Students really got into that. One of the most popular questions was students looking at whether, I'll make sure I get this one correct, venomous snakes, venomous lizards, according to the students' findings, seem to be more closely related than venomous snakes to non-venomous snakes, which when we shared that with the Flinders Uni people involved, they were not surprised. That was a suspicion that they had anyway, but this is, so they go, oh, this is worth looking into further. A couple of others at random. Smart money. This is one that was 100% chosen by students. They wanted to find more about, I guess, the maths involved in managing money. So interest rates and loans and superannuation and taxes. They'd heard of tariffs that have been in the news, not surprisingly, for the last year or so. And what is this thing? What is this thing? Smart money is what, like, in terms of a unit, was sold out. Every rotation it's running at least twice. It is the most popular module there. First aid fundamentals.
May has a request. Ghost in the Machine.
Okay, Ghost in the Machine. Sorry, missed that one. So Ghost in the Machine It's not the clearest of title. I admit that. What it's there is it's looking at essentially that murky world of AI and psychology and that kind of overlap between those two worlds. So I know students, it's very open-ended. Some students looked at how do we model human brains? How do we model human thinking? How does AI model human thinking? Is it the same? Is it different? Those kind of things. A lot of students who took it as a very ethics focused, like, is this okay? Is this legal? What comes next? So there was almost like a science fiction aspect to this at times where students took it above and beyond. So I talk about first aid fundamentals. It's one of my favorites because students, not only do they get the learning that we've, like, I guess, the learning in the classroom, one of the things they're going to get out of this is recognized with a first aid qualification. Okay, so I don't know about you, but having 100 extra people in my school site that are first aid qualified makes me feel a little bit safer. And many of these students, there is a lot of places in Australia where you have this qualification. You also get a little bit extra bonus in your paycheck each week. So students are very keen for that. Choose your own adventure. Basically, that students get into that, and the response, or our role as teachers, is to go, well, what do you want to learn about? Okay, so they may put their hand up and go, well, I need to learn some maths, and I've got 4 weeks to learn my maths. And so the teacher's role is supporting them to make the decision about how they learn their topic in the way that they want. Not every student's cup of tea. I think some students don't like making those choices. They don't choose those topics. What's another one? All bad science. Given, I guess, the news in the last 24 hours, I think it's kind of topical. What this one is looking at is decisions and actions in science that aren't great. So we've got people who are using, like, I think it's having to explain to students, sometimes scientists, we like to model or pretend that they're kind of infallible and always clear-headed, clear thinkers. Sometimes scientists can be jealous and petty and rude and vindictive, and they can ignore data and they can lie about data. So I guess what we're looking at there is, how do scientists or organizations do the wrong thing about data? I really like this one because the science that students use to explore those ideas could be whatever it wants. Like, if it's physics or biology or biochemistry, geology, it doesn't matter. It's all about, what does quality science look like? Okay, and it has characteristics. It doesn't necessarily have specific knowledges attached to it or curriculum areas. One thing, I think this is my last slide, I'm running out of time. One thing I want to point out is, teaching these modules, certainly what I'm finding is, because students have had the ability to choose something that they really like, and there's quite a big choice. In many ways, I'd say possibly too big a choice sometimes. Managing 18 different modules has not always been easy. Those students who sit in your class and go, it's not for me, I don't care, I'm not interested, like, they've chosen it, they're in the room. I'm not going to say it's eliminated that problem, but it certainly massively reduced it. And if a student has found out that they don't really like sports science, I think talking to a lot of them, they can rationalize, well, it's only 3 or 4 weeks. I'll give it my best shot, and it's not the end of the world. And so we're still getting, I think, my gut feeling is the engagement of this model is superior to the standard central study approach. I don't have any data from that. Maybe that's a really good example of bad science. But thank you very much for giving me the opportunity to present. As I said, we're just over halfway through. It's too early to call it a success, but it's looking very, very positive. Thank you all. Any other questions?
Thank you, Andrew. I've got many questions, and I will have a long conversation with you. But I'm going to open the floor to all the participants. Do you have questions that you really would like to find out from Andrew? Oh, really?
You can write it in the chat if.
What about May? Are you hearing me?
Yeah, I come in the Zoom a little bit late, but
It's okay.
have to hear about the 18 module. So I'm waiting for your question, Chan. You always ask good questions.
Okay, before I already asked one question midway before you come in. What about the other participants? Do we have questions from the rest of our guests here? Oh, there's one in the chat, Andrew. Did you see it?
Oh, must miss, where am I up to? Oh. So I've got the chat. No,
I
chat.
don't see it in the chat.
No, I can't see any questions in there.
Okay. So Andrew, I'm going to, hop the airtime and ask you a question. I don't know if it is a burning question for people, but as a teacher, I am very curious. Having this module, first, okay, I've got multiple questions. Let me rank order them. First question is, do you run this model only in the second semester, or is it just that you are starting this semester? So question number one. Question number two, this modular system, I hear you, the students choose 4. Aside from these 4 modules, are there other core modules? Because that leads to my third question, which is, with this model, as a teacher, I am very interested to find out, how do we address the demands of the individual subjects? I imagine we all have our national curriculum. How do we, through the modules, address and meet the demands of the individual subjects? Okay.
So, my question 1.
Yeah.
So this is only started in the second half of this year, so it's a semester 2. This is the first time we've done this, so I can't even say we've always done it like this. We're trialing this for the first time this year. The question about what about the core stuff, like the core coverage of the content. So I guess what we're looking at, in terms of dividing up across the central studies, it's divided up who covers maths and science and what we're covering, what's being covered where. If the decision was made that this is a key concept that everyone needs to cover, probably we'll put most of it in sustainable futures and engineering a monster, because every student is doing those central studies. I'm not going to say every part. There's some streams and modules within them as well, but it's in there. Students, if a student is going on in their next years of learning to look at a biology-rich pathway versus a technology pathway with computer program versus I want to be a biologist, they don't need to cover the same content, but we do need to address the same set of science skills. So what we're taking advantage here is that we can provide opportunities. If we go, now everyone needs to do a scientific investigation, but that's the key learning we're doing. What science is it in? Much less caring there. Psychology, biology, chemistry, doesn't matter. So I guess that's how we've organized X and Y, which is very much what are the core skills. And then in that module, you need to do designing a scientific investigation. Okay, what science it is, not as important. Okay. Having said that, the maths learning that we're doing, if we're assessing maths, it's the same chunk of maths content. It's around rates of change and introduction to calculus. That's kind of what we're looking at there. So the modules that have maths learning, it's the same maths learning. It may be more than that, and there's certainly some modules with significant maths learning that isn't assessed as maths learning because it fits. Maybe I know the students who are doing computer programming in the Code and Create module, and their software, their game is about probability just because they're interested in it. I think that answers the question.
Thank you, thank you. Others? Any questions from the other teachers? No, maybe. If you have more questions, you know, continue to put into the chat. For me, certainly I benefited. It's a very new model, and then I've got a lot of questions marked. And you know, you going back to that infinity diagram helps me understand a little bit of the organization of the various modules.
Yeah.
And now I understand the X and Y. Thank you very much, Andrew.
Oh, thank you.
Yeah. If you're able to, please stay on for the next presentation, but I understand that the time it's a little bit late at Australia.
That's right. I can be here for a bit longer. This is very interesting.
Yeah. All right. So can you stop sharing, and then we'll move on to the next presentation.